Okay, in this video we're going to start 7.3, solving trigonometric equations. In the first video we'll probably get through these first two bullet points, use standard algebraic techniques to solve these trig equations, and solve trig equations of the quadratic type. And then the next video we'll do the multiple angles, and the last one will be using inverse trig functions to solve trig equations. Have your unit circle handy, that's going to be your best friend as we go through this section. I'll start out with a nice slow one here. Here's 2 sine of x equals 1. What values of x make that true? So in algebra we would solve for x, something like 2x equals 1. We'd divide by 2 and get x is a half. And here we are just solving for the trig equation like we would solve for x in just basic algebra. So here we're going to divide both sides by 2 and we'll get sine of x equals a half. Well, where on the unit circle does that occur? Sine is our y-coordinate, and it's positive a half, so we know we're going to be in the first two quadrants. Again, sines are our y-coordinates, and we have a spot here on the unit circle that goes pi over 6 radians, and our x-coordinate is square root of 3 over 2, and our y-coordinate is positive a half. So this occurs at pi over 6. And also there's another spot reflected around the y-axis where we have a negative square root of 3 over 2 x-coordinate. And our y-coordinate is positive a half. And that occurred at 5/6 pi radians. Or if we remember our reference angles, here is a pi over 6 reference angle. So they have the same y-coordinate. So where does sine of x equal 1/2? Well, it occurs at pi over 6 radians, and it occurs at 5 pi over 6 radians. And then remember the unit circle, we can just keep doing laps around and around. Every lap is another 2 pi. So we're going to have sine of x equal to a half at a 6 pi radians, plus every 2 pi after that times some integer n. N is just an integer. So pi over 6 plus 2 pi n. Plus 4 pi n, plus 6 pi n, and so on. And the same for our 5/6 pi. Here we can just do another lap around the unit circle, which would be another 2 pi times some integer n. In example 1, a little more complicated here, but the idea is the same. We have a trig function. It's sine on both sides of the equals, so we are going to try to isolate the sine of x. So here I'm going to add sine of x to both sides. And I'm going to get 2 sines of x equal, and here's a positive square root of 2. I'm going to subtract that from each side. So on the other side I'll have a negative square root of 2. And now I want to get sine alone, so I'm going to divide by 2. So we know that the sine of x equals negative root 2 over 2. Now where does that occur? Here's a unit circle. Sine values are y values, so we're going to be looking in the bottom two quadrants, 3 and 4. We're looking for y values of negative square root of 2 over 2, and here's one of them. And here's another. What angles made those possible? Let's see here. That is 7/4 pi. 7 pi over 4. And the other one is 5 pi over 4. 5 pi over 4. And just like in the previous example, that's going to occur and then every lap around the unit circle thereafter. So it's 7/4 pi plus every 2 pi after that times some integer n. And we have our 5/4 pi plus 2 pi over n. In example 2, the technique they're telling us to use is extracting square roots. And warning, remember, when we are extracting square roots, that means we're going to take the square root of each side of the equation. We have to account for both positive and negative solutions. Like when we had x equals the square root of 4, it would be plus or minus 2, or x squared equals 4. If we had something like x squared equals 4, we would square root each side, and that would be x equals plus or minus 2. So here we're pretty close. We just got to get our tan squared isolated. So the first thing would be to add 1 to each side. 3 tan squared of x equals, we'll add 1 and it'll be positive 1 on the other side. Divide by this 3. So we have tan squared of x equals 1/3. And then we want to square root both sides. And I like to do numerators and denominators separately. So we're going to have the tan of x equals plus or minus, the square root of 1 is 1 over 3. Oops, square roots of 3. And then we want to rationalize our denominator. So we'll multiply by that denominator, root 3, and we will get plus or minus the square root of 3 over 3. So let me rewrite that here. The tangent of x equals plus or minus the square root of 3 over 3. So in these last examples, we had 2 answers. Here was 1, here was 1, and then our 2 pi laps after that. The same in the first, there were 2 answers, pi over 6 and 5 pi over 6. Here our sign value was positive, so we were in the first 2 quadrants. Here our sign values were negative, we were in the bottom 2 quadrants. Now we're dealing with positive and negative, so that means we're going to have up to 4 answers on the unit circle. So here's a unit circle, and tangent isn't just one of our coordinates. Tangent is sine divided by cosine. And if we do this sine value, square root of 3 over 2, divided by this y value, 1/2, the square root of 3 over 2 divided by that is the same thing as multiplying by the reciprocal. Oops, I got that backwards. Sine divided by cosine. Sine is 1/2. Our y value is sine. 1/2 divided by the square root of 3 over 2 is like multiplying by its reciprocal. 2 over root 3. Those will cancel. We'll have 1 over root 3. And when we rationalize, we'll have our tangent equals square root of 3 over 3. So this is going to be a solution anywhere we have the x-coordinate of root 3 over 2 and the y-coordinate of 1/2. And it doesn't matter if they're positive or negative. So we're going to have that right here. And the reference angle in the second quadrant, we're also going to have that at 7 pi over 6. Our x and y coordinates are the same, except the signs differ. And the same thing here. So we do have 4 solutions. But we can write this a little better than we did these two. Here we wrote one solution and had plus 2 pi n, and another solution and another plus 2 pi n. We could do that here. We could write pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and I might as well write these down. Pi over 6, and then we have our 5 pi over 6. We have 7 pi over 6, and finally 11 pi over 6. So here are 4 places on the unit circle when this, or where this occurs. And we could have each of these answers plus 2 pi n, plus 2 pi n, plus 2 pi n, and so forth. Or we could just pick 2 of them and just, instead of adding 2 pi n, add 1 pi n. If we are here at the first quadrant angle, pi over 6. If we add 2 pi, we'd go all the way around. But if we add 1 pi, 1/6 pi plus 1 is 7/6 pi. So we could take this pi over 6 and instead of adding 2 pi n, add pi n. And that takes care of this solution. And we could do the same thing here in the second quadrant. Here we have 5/6 pi. If we add 2 pi, we'd do a lap, but if we add 1 pi, it would take us here to 11/6 pi. So we can take 5 pi over 6 and instead of adding 2 pi n, add pi n, and that accounts for all solutions to this trig equation. In example 3, we're going to have to factor a little bit. An algebraic technique is to factor, get everything on one side, set it equal to 0, and factor it. And that's what we're going to do here. On the left, we have cotan x, and here we have a cos squared of x. On the other side of equal, we have 2 cotan x. If we subtract that from both sides, we'll have a minus 2 cotan x on the left, and now the whole thing's equal to 0. And I see a cotan and a cotan in each of these factors, so I'm going to pull that out front, and we will have the cotan of x times, left-hand side we have a cosecant squared of x, and minus 2, and that's equal to 0. And remember this algebraic technique, since we are multiplying two things and the product is 0, we can set each one separately equal to 0. So first, we'll have cotan of x equals 0, and cos squared of x minus 2 equals 0, and let's add 2 to both sides right now, so cosine squared of x equals positive 2. So we have these two paths to take. On the unit circle, when does cotan equal 0? Well, cotan is not one of our coordinates, but it is a reciprocal. Cotan is the reciprocal of tangent. Ooh, and we'll just have to divide. Cotan is cosine divided by sine. When does that equal 0? Well, that equals 0 when the numerator equals 0. We can never have the denominator equal to 0. When the numerator equals 0. So where on the unit circle does the cosine equal 0? That cosine is our x-coordinate. That happens at pi over 2 and at 3 pi over 2. So here we'll have pi over 2 and 3 pi over 2, and then every lap around the unit circle after that. Or since these are 180 degrees apart, we can say our solutions are at pi over 2 plus pi, and then plus another pi, and plus another pi. So we can do the plus, not 2 pi n, but pi times n. And that will account for the solutions down here on the negative y-axis. So we can get rid of that. Now on to the other side. Here we're going to have to extract square roots. If we root both sides, the square root of cos squared is cos x. When does that equal the square root of 2, or the square root of 2 divided by 1? That's going to occur nowhere on the unit circle. Remember, cosine, it's restricted to numbers between 1 and negative 1. It's less than 1, it's greater than negative 1. The square root of 2 is more than 1. So this is no solution for this root we were taking. We did have some solutions over here, but there are none for this factor. And that brings us to some practice problems. Pause the video, try the problems out, unpause the video, and check your solutions. Okay, let's check out this first one. This is a lot like the first example, simple cosine function. We want to isolate cosine, so we are going to subtract 1 from each side. 2 cos of x equals negative 1. Divide by 2, and we get the cos of x equals negative 1/2. Cosine values are x values, and we're positive. So negative. So x values are negative on the left side of our unit circle in quadrants 2 and 3. Where does cosine equal negative 1/2? Well, right here and right here. So that would occur at 2/3 pi, and down here at 4/3 pi. And every lap after that, every 2 pi times some integer n. So another plus 2 pi n. Here we have a squared term. We can either, well, looks like we're going to have to just extract the square roots on it. So let's get the secant squared by itself. So we're going to add 4 to both sides. 3 secant squared of x equals 4. Divide both sides by 3. The secant squared of x equals 4/3. And now to extract the roots, we will take the square root of each side. And we come up with the secant of x equals the square root of 4 is 2, the square root of 3 will stay square root of 3, and we have plus or minus since we square rooted both sides. Now secant is not one of our coordinates on the unit circle, but we can flip it over. Remember, if we flip over secant, we get cosine. And when we flip over 2 over root 3, we get root 3 over 2, and now we don't have to worry about rationalizing a denominator anymore. So, and this is positive or negative. So there will be 4 places this occurs on the unit circle, and we'll probably have our answers, and then we'll add our plus pi n as opposed to 2 pi n. So cosine values, those are x values, root 3 over 2. Root 3 over 2 positive, root 3 over 2 negative, root 3 over 2 negative, root 3 over 2 positive. But we only need 2 of these, remember. We can take them from the first 2 quadrants. So here in the first quadrant, that occurred at pi over 6. And then if we added 1 pi to that, that would take us here to the 7 pi over 6. And we also have it occurring at 5 pi over 6. And here at 5 pi over 6, if we add 1 pi, we'll get to this other one in the fourth quadrant at 11 pi over 6. So we are going to add not 2 pi n, just a pi times n to account for all possible solutions. And finally, number 19. This looks like another one. 2 ways to look at it. We could extract square roots like we did last time. Add the 1 to both sides, divide by 4, take the square root of each side. Or this is a difference of squares if you see it. We have one term that would be 2 cos of x plus 1. And then we'd have another term 2 cos of x minus 1. And set that equal to 0. And if we set the first term to 0, we would subtract 1 from each side and divide by 2. And get the cos of x equals negative a half. And then here, if we solve this equal to 0, we would add 1 to both sides and divide by 2 and get cos of x equals positive a half. And you know, that's the exact same thing we would have got if we would have extracted the square roots. We could have added 1 to both sides and divided by 4 and got cos squared of x equals a fourth. And then when we square rooted each side, we would get the cos of x equals positive or negative. The square root of 1 is 1, the square root of 4 is 2, plus or minus 1/2. Here we just see it separate into 2 different roots. So we're looking for anywhere our cosine value is a half, positive or negative. Well, our x values are cosine values, so that's going to occur in the first 2 quadrants here, and in the third quadrant at 4/3 pi, and at 5/3 pi. So again, there are 4 solutions, but we only have to really write 2 of them. So our answers are x equals pi over 3, our first coordinate angle, and every 1 pi after that, plus pi times n. And then we have another solution here in the second quadrant, that's at 2/3 pi. And every pi n after that. The assignment for this section, page 564,